Okay, good afternoon, everyone. Today we're going to discuss the features of the chosen software that we're going to use for this subject, financial analytics. We're going to use R. So let me backtrack a bit and have a quick review. We said that you can download R, install R in your machine by typing Quran, Google it, and the first line there that you're going to get is the comprehensive R archive network. So that stands for Quran. So this is a repository of everything about R. So you can see here about our homepage, the R journal. You can see here packages. As I mentioned a while ago, packages are the programs that have been contributed by people uh, who know how to program using R, and then who are experts or who are knowledgeable in their own fields of knowledge. For example, chemistry, physics, biology, chemistry, mathematics, calculus, okay, and abstract algebra, social sciences like sociology, physiology, political science. Okay, if you click this one, packages, you can see here a whole range of programs, right? So here you have, there are 22,639 available packages. So that's quite a lot. That's a lot of programs. And inside programs are very powerful functions that you can use when you're doing your statistical analysis or whatever, or your research. So if you, for example, table of available packages sorted by date of publication. If I click this, okay, so these are the packages that are available in CRAN, archived in CRAN. So we have the latest one is today, uh, August 5, runs allele match regression test. And we have high level modeling function, etc. For hypothesis, third edition. So there are a ton here, okay, from different fields, different subjects, different topics, whether it's natural sciences or social sciences, okay, field. You have many packages, and again, a package is a particular. Uh, it's a program created by people who know how to program in R, and then they share it with CRAN, and CRAN vets it and checks if it's okay, and then if it's okay, then it's shared to the community. Okay, so the community has access to this one. Okay, so since you have R already, you can access any of the 22,000 packages that's available in CRAN. So you don't, but of course we're not going to use everything there. I think we'll just be focusing on around 50 or even less, 50 or a bit more packages. Okay, so let's go back here. Okay, you can sort it by name. If I click this, okay, so it's now alphabetical. Okay, for example, I go to letter G, and there's this package here called ggplot. Let me, which we're going to use also. For example, this one, ggplot2. GG, okay, letter P. PLO here, class, ggplot2. So this is used for creating elegant data visualizations using the grammar of graphics. GG stands for the grammar of graphics. So this is a very important package as far as data visualization is concerned. And it has generated a family of other packages. For example, here, GG pattern. This is used in consonance with ggplot2 and several other grammar of graphics plots. You can see here there are many GG packages here. Okay, so as I said, our choice of software to use in this subject is warranted. Okay, we'll never get wrong with the use of R for our topics. I'll discuss on Friday what are the topics that we'll cover here: portfolio optimization, time series analysis, machine learning, and other very important topics for financial analytics. All right, so let's now go back to the other one that I was saying, RStudio. Okay, note that the name now is POSIT. It used to be the name is only RStudio, but there's a reason why they changed the name to POSIT. But let's click this for the benefit of those of you who haven't downloaded this one. What is RStudio? So it's a sorry, it's what we call an IDE there. IDE, which is an integrated development environment. So what is it for? It's used in consonance with R. So it's a set of tools built to help you be more productive with R. So before it was only called RStudio, but because now you can also use RStudio or POSIT to create Python codes. That's why the name was changed to POSIT to reflect something more of a flexibility on the part of this software, where you can create either R or Python. Okay, Python itself has other IDEs like Jupyter Notebook, etc. Okay, but for R, one of the best, if not the most important IDE is RStudio. So we'll stick to RStudio. So just like R, this is free. Okay, so if you go here, notice that the step one is install R. And what's the reason for that? You cannot install R. You cannot install RStudio unless there's R. So that's the first step. You have to install R first, and once you have R, then you can now install RStudio. So for those of you who are following along, please click this, and of course choose. So which one are you using? Are you using Mac? Then choose this one. Are you using Windows? Then choose this one. If you're using Linux or Ubuntu, then choose this one. I guess nobody's using Ubuntu in this class. All right, so once you have that RStudio, then same thing, okay, in your search tab here, you can type RStudio, okay, then once again, the app appear here, and then if you click this, then you'll have choices here, okay, here. So pin to the taskbar so that it will appear here. Okay, so this will appear, this RStudio. So let's give your classmates a few seconds to confirm. Sorry about this. To confirm if they have already, if they have, okay, let me going to our G drive. Okay, kindly confirm please if you have already downloaded RStudio. For those of you who are just downloading it now. Okay, 32.5, 32.5. I guess those of you who downloaded it, okay. The rest of you who either, so ito, no, si Janine, please do that, no? Make sure that before our class on Friday, you already have downloaded R and RStudio. For those of you who are here and who have not downloaded it, okay, make sure that before our class start on Friday. In fact, I'm going to request you to please watch the video Okay, you can of course watch this one, Introduction to R, RMD and R Notebook. More importantly, I would that you watch this too. The video on data types and structures too. So the file that you can use for this one is this one. All right, so that should be an assignment for you because we're not going anymore to discuss this. This will be an assigned, a required viewing and studying on your part. And why is that so? Because we would want to save on time because this might take long if we still have to discuss that. So please invest in a few hours class in order to follow along in those videos. Okay, could you kindly check if this is accessible, please? Check, please. If you click this, does it lead you to YouTube?
Yes po.
Okay, good. Okay, thank you. And also this one, the part 2. So it's imperative that you watch those videos for your own sake because we will not have time anymore to discuss this. They just discuss the different types of data. So it's easy to follow if you're going to invest in time. Okay, so I hope you do that. Okay, thank you. All right, so let's uh, okay. So may I request you to please, what happened to my, uh, uh, sorry, can't see my, can't see my, okay, I have to close this because it's blocking my, here, wait. Close this. Okay, there. It was blocking my taskbar. Okay, so let's now open an instance of R. So this is the logo for R. You have the letter R, and then you have this oval here beside it, at the back of it. So if you click this, okay, if you click that, this is what you get. Okay, let me, so that we have the same. Okay, close it, click R. Okay, this is what you get, class. So you have this window here. It's called the console. Okay, and then at the back of it, you have a, a grayish empty space. So this is what you get when you open R. Okay, and as I said, I would that you, it's best for you to create a shortcut so that you can easily access it. So our version 4.5.1, we know this because when we downloaded R, we were told that the version is 4.5.1. Okay, and it's called the Great Square Root. Okay, as I said, every now and then, every 3 months, R updates its version. Okay, so R is just like a very, very big computer. Okay, so I can type a mathematical operation here. For example, okay, so I'll have to reach out sa number, sorry class. Okay, 897. Okay, let's say plus 345. I'm just uh, minus, okay, log of 345. and then plus exp to the 34, okay, divided by the square root of 999, okay. I'm just guessing, I'm just putting here any term, plus sine 45, okay. All right. Okay, then maybe let's add minus, okay, maybe minus 98765, okay, raised to the 1 over 3. That's cube root. Okay, so we have here, we have an exponent here. So this could be caret 2, that means squared. So this is just any ordinary mathematical operation where you add, you subtract, and you divide. You don't have any multiplication here. We have an exponentiation. Okay. So if you type any mathematical operation like this, and then press Control Enter, so that's how you make R run that function, Control Enter, you'll notice that it will automatically, very quickly, give the answer. It's 1.84599 times 10 to the 13th power. So you can see how very powerful this machine is, this software is. Not only that, you can create objects in R. There are many things that we can do with R. The things that Python can do, of course, R can do, and many more. Okay, so let's say I'm creating an object called X. Okay, and then I'm using this. This is called your assignment operator. So it's a less than and then dash. Okay, and let's say it's 3987. So what does this mean? I'm assigning the value 3987 to an object called X. Okay, so if I run this, Control Enter, okay, then X will recognize that, R will recognize that if I use X, then I'm actually referring to 3987. So let's have another one. Let's say Y, shift, that's done, and then let's use exponential of 45, e to the 45. And then let's create another one. So Control Enter again, and then Z. And then Z is shift. Let's say it's 345, and then say fourth root. There. Control Enter. Okay, so I now created 3 objects, X, Y, Z. So R will recognize what X, Y, Z is. And I can use that, for example, if I do X divided by Y, okay, and then plus Z. So I'm now creating this operation where X is to be divided by Y and then add Z. Now take note, okay, R will recognize this because we already created an object called X, an object called Y, and an object called Z. So if I run this, Control Enter, there you go. It generates an answer, 4.309777. So that's the answer for that specific operation, X divided by Y plus Z. Okay, now not only does R compute or create objects and then perform operations using those objects, R is also a very powerful plotting software. So let's plot, for example, an object called pressure. Okay, plot pressure. Now what's pressure? Pressure is a data, okay, that's preloaded with R. When I say preloaded, it means that when I access R, when I open R, you can access this data. Okay, so if I run plot pressure and then again Control Enter, now notice that there's a window here that will appear. And this window is the plots window. And you can see that the data pressure consists of the y-axis, variable name, pressure, and the x-axis, temperature. And it's a plot, a two-dimensional plot of this data set. Okay. Now you can also summarize what's inside the data. So for example, let's use, okay, let's see, for example, I can use the head function, okay, plot, and let's see what will be generated by the function head. Control Enter. Okay, I'm sorry. Sorry. My mistake. Head, not plot, but rather head is the plot is the function. I would like to see plot head of pressure. So it will give us the first 6 observations. Okay. So the head function will give us the first 6 observations of the data plot. So you can see here the data plot is temperature and pressure. So if I want, okay, so Control Enter. Okay, if I want, for example, to print the whole data, I'll just type here print and then pressure. Control Enter. Then it will give us 19 data points for pressure, the object pressure. It has temperature on the y-axis and pressure on the x-axis. That's why you have this plot here. And not only that, we can use what we call the summarize function. Summarize pressure. Summarize pressure. Let's see what happens when we, could you tell me, class, what happens when we run this summarize pressure? Could you put in the chat box what is the result of summarizing the object pressure? So I'll see. I'll wait for your comments, your feedback. Okay, may I request, class, that when you answer, please share your answer to everyone. Error, okay? Both po are accessible. Ano yung error? Yung summarize? Could not find. Sorry. Oo. So, yeah, I deliberately did that, class. Kasi I wanted to show you, class, that R is very particular about spelling. So this is the wrong code, class. This is the wrong function. In my case, if I press Control Enter also, it's also wrong. Okay. So if I press arrow up, it will produce arrow up. It will produce the previous codes that I wrote here. So arrow up, and it will generate the latest one. And I'm going to change this. Okay. And that was meant to, okay, tell you how sensitive R is to spelling and using the right function. So try summary pressure, and please tell me what happened. Summary pressure, what does that yield? All right, thank you, Jerry Lane. All right, so you now have, you can see that summary, yes, thank you, Therese. You now see that the summary function will give us the 6 number summaries. You have the minimum and you have the maximum below. Then first quartile, median is the second quartile, third quartile, and also the mean. So you have 6 number summary. It automatically computes the minimum value, the maximum value, the first quartile, or the percentile 25, second quartile, percentile 50, okay, and the third quartile, percentile 75, which are topics that you learned in your basic statistics. Okay, so you can see how powerful R is in generating outputs like this. We can also, for example, let's choose another data, cars. Okay, not summary. Let's plot first. Plot. Plot cars. There's also this object called cars. It also comes pre-packaged with R. Okay, so let's plot this. Control Enter. Plot. And you can now see a plot of the object cars. You have distance and speed. Okay, the plot appears in another window, the graphics window. So if I get this time tail, so a while ago we used head. This time let's use tail, tail, tail cars. And then let's say I put here 2. What does this mean? Heads will give us the first here. Head pressure, it will give us the first 6 observations. Okay, that's the default, 6. Although there are 19 observations here, it only gave us the first 6 because that's what the head function does. If you want only the first 2, then use head pressure then comma 2. So that's what we're going to do here. Tail this time will give us the last data, last observations. Tail cars. If we don't write any number there, it's the last 6. Here I'm putting 2, which means it's the last 2. Control Enter. And you can see here, observation number 49 and 50. So we can deduce that there are 50 observations in the cars dataset. Okay, if you want to be sure, you can just type cars or print cars. Okay, you can use the one that we used a while ago, print, or just print cars, or just use cars. Control Enter, and then true enough, there are 50 observations, speed, distance. The last 2 are this one. This is what we asked for a while ago. Okay? All right, and of course, we can also do the summary for cars. Okay, Control Enter. The summary function gives us the 6-number summary, minimum, okay, the maximum. Okay, let's check that minimum. Okay, minimum of what? Now take note, we're using cars object. However, we have to identify which variable in cars, sorry, are we getting the minimum? Sorry. So it should be, wait a moment, class. Okay, cars, and then what we do is we type dollar. Okay, type dollar, please. Okay, cars dollar. Okay, because what we want is to get the minimum of speed. And if we just use, let's say, okay, let's just use minimum cars. Control Enter. What do we have? We have 2. What's 2? Okay, 2. What happens is that R will get the minimum of the whole data set. Okay, the minimum of speed is 4, the minimum of distance is 2. So it uses all the data set and then gives us the minimum. But if we want to get the minimum of speed, the variable here, then what we do is minimum, and then cars, the data, and then dollar speed. That way we're telling our, I want the minimum of, from the cars object, I want to get the minimum of the variable speed. So Control Enter, then that gives us 4. Okay, so if we want to get the maximum, this time maximum of, say, cars, and we want to get distance, the maximum of distance, of course, I'm very confident that it will give us 120. Control Enter, 120. Okay, you can also use quartile. Let's see if I remember the function. Quartile of cars. Let's say quartile cars, and then let's use speed. Quartile 1, first quartile. Let's see. Quartile Okay, error. Okay, I think, wait, it's not quartile. So, is it quart? Let's see. Control enter. All right. I'm sorry, I forgot the code to get the quartile. We'll review that. Or maybe you can Google class. Can somebody Google please? Uh, how to get the quartile, the first quartile in a data in R. Can somebody do that please so that we were able to answer that question already? Quartile. Okay, I forgot the code for that. Yes, thank you. I have an answer here. Okay, what's the quantile pala, quantile, sorry. Yeah, it's not ano. My apologies, cause quantile, sorry. Quantile. So thank you. Thank you, Lara. So we use quantile, quantile, yeah, it's quantile. And then cars, dollar, speed. And then which quantile? Quartile 1 is 25th quantile. Okay, so I think this is the right one. Let's see if quartile 1 is the fifth. No, wait. I think it should be 1 also. 1. Let me check. Otherwise, we'll use percentile. Control enter. There you go. Okay, it's 25. No, 100%, 25. What is it? Speed. It's supposed to be 12. So what did I do wrong here? Sorry. This is the percentage. Okay, my bad. So it's not 1. Okay, 1 means 100%. So that's the maximum. So since we're getting the uh, first quartile, and the first quartile is 25%. Okay. Okay. So I think this is the right code already. There you go. 25%. Okay. So many things more to discuss. For the whole term, we're going to use R. All right. So you can see that our you can see that we can generate tons and tons of output here. However, there's one distinct disadvantage. It's now difficult to create a report out of this. So enter RStudio. Okay, enter RStudio. So if you open RStudio, please, okay, click RStudio, click this one. And you'll notice that you will be brought to, okay, let me first make it similar as yours. Tools, global options, okay, pane layout, and then appearance, I'll make it Chrome. Okay. So when you open RStudio, you'll be having this. Okay. Of course, you notice that when you open RStudio, there will be 4 window panes. In case you don't see 4 window panes, usually you only see 3. The console here is hidden. You can just go here below, and then you can see here, there are 2 boxes here. One is to maximize this one, the whole console, and the other one is to share it. I'll click this, and then you notice now that there are 4. There should be 4 window panes. What are those 4 window panes? Number 1, you have the source window. So this is your source window pane. Number 2 is your console. Number 3 is your environment. And number 4 is your files, plots, and packages window. Now, of course, we will not have the same displays here. Okay. Now, if you notice, this one is the same as the one when you opened R, diba? Ito yan, no? R version 4.5.1, everything the same. Okay? In fact, para same name, R console. Okay? 4.5.1. Okay? And also, dapat wala ito, no? Wala. Kasi uh, hindi pa natin, we haven't created a project yet. We're going to create a project now. Okay, so now what I do is that okay, I prefer putting the console here on the upper right. It's just my own preference. You might wish not to follow this, and the environment below. I'll tell you why. If I copy the code that we generated a while ago, let me copy this. Let me copy the equation here, the operation, this one. Control C. I'll go to RStudio. Okay, and then copy it here to my script window. Okay, this is the same operation that we wrote a while ago. Control Enter. You notice what happens. The answer is not generated here in the source window. The answer is generated here in the in the console here. So what happened when you write a code here? The code will be replicated here in the console, and then the answer will be given. Just like the one that we did here in R, diba? When we run this, it gave the answer. And this is the console. So same thing here in your RStudio. You don't have only one interface. You have four. Okay, so let me explain what these are. This is your source window. This is your console. This is your environment window, very important. And then this is your files, plots, and packages window. Now, as I said a while ago, my preference is that the console be placed on the upper right because when I run the code here, automatically the code will also be produced on the right side, and then I can immediately see the answer. Because when I have already several lines of code, and this of course will generate the code and the answer itself, so it becomes quite unwieldy, very difficult to follow along below. Okay, so how do we now change the positions? Remember, there are four window panes. We have the source window pane, we have the console, we have the environment, and we have the files, plots, and packages. So let's now reposition this. How do you reposition it? Go here to the tabs on top. Okay, but before I do that, let me just explain that RStudio will never work without R. As I mentioned a while ago, the analogy is that RStudio is like the dashboard of a car, and then R is the engine. The engine will run without the dashboard, but the dashboard will not be able to run without the engine. Okay, so that's a crude analogy, but I think it's a powerful analogy. So that's why when we installed, we did not install RStudio first. We installed R first. And what's the use of this RStudio? As I said, it's an so that independent IDE, development environment. Okay, so it's used alongside R, but it helps us navigate through the R software more easily. Okay? Kasi dito apat na yung window panes natin. Dun sa R GUI, isa lang, ito lang, no? Yung console lang. Okay, so our preference is to use RStudio as compared to R. However, of course, we know that RStudio will not work without R. So going back to what I was citing a while ago, that it's better to reposition your console. So this is the default, but for me, I prefer putting the console here on the upper right. So if you want to do that, so you can just go here to the tabs here and then tools. Below here is global options. So tools, global options, click this, and then it will bring us to this dialog box here. On the left side, you have general, code, console, appearance, pane layout, packages, etc. Notice that there's Python here, which means that you can now create codes of Python in POSIT in RStudio, which makes it powerful. So you're opening one, and then you can create one file, and then you can create both R and Python in one file. So in order to change the position of console, we just go here, pane layout, and then I want the console to be here on the upper right. I just click this, and then console. So automatically it will change positions. Okay, so source, console, environment, files. For example, if I want files to be here below, I'll just click this one. Okay, or here, files here. So files now will be transferred here. But I'll revert back to the files plots here on this side, environment on this side. Okay, another thing that you may wish to modify in your interface is the appearance. Okay, the default is Chrome. This is the Chrome appearance. You can of course change the editor font size, the line height, etc. So I leave you guys to, in fact, even the editor font. Okay, I'll leave that as is, 16 yung font size ko. Help font size is 20. And then what I'm going to choose is Cobalt. I prefer this because it's easier on my eyes. Okay, and I hope it's easier on yours too. Okay, so if I click this, okay, then now you can see that the interface has changed. Okay, the console is here, the environment is down below, and then the files, plots, packages is here. Okay, and then for this one, since this is just notes, okay, when you open R or RStudio, we can remove this, okay, so that we have more space in writing and reflecting the codes here. Okay, so let's see. Okay, before we do anything else, I just like to point out the importance of creating an R project. An R project helps us to manage our files because we might be creating several files. Excuse me, class. It's possible that we're creating several files. Okay, it's good to organize your files in one folder. Let's say, for example, we'll have a lesson on portfolio optimization. Then it's very good for us to create a folder for portfolio optimization. So we'll be discussing, for example, time series. So it's best for us to have a folder for time series. Okay, so how do we do that? We do that by, so let's first, may I invite you to either in your desktop, okay? So I'll go here. So I'll create, maybe just see one here, and I'll go to my desktop. And I'll create a folder. You may wish to name it FINLYTS, okay? I won't create one anymore, but just do that, class. And I'll just use this one, the one that I used a while ago. So I created this folder, 000 FINLYTS, okay? 000 FINLYTS. So please remember where you created that. Maybe I'll just create another one, okay? New, and then I'll just create 000 FINLYTS. I'll create 4 zeros. You don't have to do that. Just have to name it FINLYTS. Okay. So I created this one, class. And there you go. We know that there's nothing inside there. There's a question, I think. Yeah, there's a question. Yes, Janine. Yes, because this will be we're programming always. We're using R. So it's very difficult for you to follow along with the lesson if you don't have a laptop with you. Yeah. So thank you for reminding me. So may I request you to please bring your laptops with you whenever we have face-to-face classes. That's the only way for you to be able to follow. You cannot, of course, understand. Uh, this is really a hands-on thing. Okay. So thank you, Janine, for that question. I hope you are able to bring one. If you don't have one, please borrow na lang muna. Okay. So during our class hours. Okay. Now, of course, there's nothing here. I just created this folder. So nothing inside this one. Okay. So I know that what I created for my project is 000 FINLYTS. Okay. So let's now go back to our studio. Okay. Here. So what we're going to do now is to create a new project. So all the topics that we're going to discuss here should be inside a project in order for us to preserve or to save our data properly or to save the file properly. Now, I'll tell you in a minute the importance of this, the very big importance of this. So how do you create a project? So here, go to File, okay, File, and then instead of new new file, you choose New Project here. So we're going to create an R project. So click this one, and this dialog box will appear. Okay, so we're being asked, are you going to create a new directory or an existing directory, a version control? We're going to create a new directory. So click this, and then in this new directory, are you going to create a Quarto book, Quarto blog, website, etc., a website, Shiny application? We're not going to create this thing, so we're going to create a new R project. So click this one. Okay. Now, what will be the directory name? We're going to name the topics that we're going to discuss as our directory name. So since this is just a trial, so we can just put 0 and then introduction to R and R Studio. Okay, so this is the folder that we're going to create, the project that we're going to create. Then the question is, create the project as a subdirectory of what? Okay, this is the project, this is the folder that we created. So go here to browse, and I'm going to go to my desktop, and this one, 000 FINLYTS, the one that I just created now. So choose this one and then open. Click it and then open. You don't open the folder itself. Just click this. Okay, so it will be a subdirectory of FINLYTS 000 in my case. Okay, and then open. And let's see what happens. And then before you click create object, click this one, open a new session. Open a new session, okay, and then create project. Okay, there you go. So let's wait. A new instance of R Studio will open. Okay, but there will be something different about this as compared to the first one that you opened. Remember a while ago I asked you to open a new open R Studio. Okay, so take note. On the upper right hand, left hand, you can see that, okay, there is this name, 0, Introduction to R and R Studio. This is the project that we created a while ago. And that one can also be seen here. In the console, you can see here, C, in my case, users, home PC, desktop, 000 FINLYTS, and inside that is my project. Okay, and also here, you can also see it here. Okay, can you please confirm if you got this, class? I hope you were able to create a new project inside the folder that we generated a while ago. May I have confirmation from your end, class, please? Just a yes, class. Okay, good, thank you. Okay, good. All right. So I hope those of you who were with another class, I hope you're learning something new. I don't know if you discussed the R project, but for us it's very important. Okay? All right. So thank you so much for your feedback. But next time I hope that there are only one, two, three, four responses. You are 39 all in this class. So I hope next time I get more responses from everyone. Okay. And then please, when you respond, please direct it to everyone. Okay, because it always reverts back to you when you direct message it to me. All right. Okay. So we're now in the project that we created. Now to test class, let's go to open the folder that you created. This one, 000 Finlits in my case. And if I click this, notice what happens is that there's a new folder here. The folder, the directory that was created is this one. 0 Introduction to R and R Studio. This is the project that we created. So next time when we're dealing now with time series analysis, then we create another project, one time series, etc. And all the lessons that we're going to have will be created in folders. Okay, if I click this one, class, what do you have here? You have this one. Okay, it's an R Studio project file. If, let's say, all right, I'm sorry. So let me close this. Okay, I'll close this. Okay. Okay, I closed my R Studio. Okay, what is this? This is different. Multiple regression. Okay. All right, what happened? So we now closed our project. And if we go here to our uh, here, okay, 00 Finlits, this one class, our project. If I click this, what happens? If I click this R project, it will open the R project that we have created. If there are any files that we created a while ago, it will be there. So here, it's still the same, 0 introduction, and then this is the site, and then, okay, again, the introductory uh, notes from the console. I'll just delete this. Okay. Now what we're going to do is I'm going to copy the codes that we generated here. Okay. Let me copy this. Okay, I'll just copy this, Control C. And then Control V. And then I'll just delete this. I'll delete the answer here. This is the answer. Okay. And you have to remove the cursor there because that will not run here. Okay. So I copied the code that we did in R. Okay. And once again, I'm going to run this. Oops, square root. Okay, here be 1/3. Okay, I wasn't able to copy it, and whatever that number is. And then you notice that if I run this, how do you run this? Again, go anywhere here, and then Control Enter. Then, as we know, the code will be regenerated in the console, and then it will drop the answer here. So for this one, I created an object called X. Okay, and notice in the environment, an object was created X, and this X is 3987. It tells us that R recognizes that the value for X is 3987. Okay, and then for this one, Y, Control Enter. Y is EXP45. So that's a big number because that's around 2.8 times 10 to the 45th. 2.81 to the 45th power. It's a big number. And then let's also generate this Z. Okay. And then you have here X, Y, Z. And if I run this, notice that every time I run the code here in the script window, it's generated here in the console. And once again, if we perform this, it reruns it here, and then it gives us this answer, 4.30977. Okay, so we already know, as of this time, that the source window, the script window, is there for us to write the code. The console will reprint the code and then give the answer. Okay, and when you're creating objects using the assignment operator X, let's say 3987 here, it will be reproduced here in the environment window. So the environment window tells us what objects are currently loaded in your file, in your R project. So X, Y, Z, okay, these are the variables that we created. Okay, so let's once again do the plot here, plot of pressure. We did this a while ago. Control Enter. Notice that the plot is not generated in the console. It's also generated in the plots window. Just like in R, you have a separate window to plot to generate your plots. Or maybe you can do plot also cars. We're just replicating what we did a while ago. And then this is now the plots for cars. Or summary for cars. Okay, Control Enter. So you notice that the answer is produced here in the console. All right. Okay. So the disadvantage of this is that you cannot create a report out of this because the answer, the answer and the code are separate, and you cannot do it using the console. So let's first save this. How do you save this? Okay, File, Save As. When you save this file, notice that it defaults to the project that we created. Okay, it defaults to the project that we created, and you know, let's suppose you forgot to save this. Okay, which happened to me. I did create a project, so I was working on a particular file. There were already thousands of rows of codes. Okay, however, my mistake was I did not put it in a project. So there was sudden power failure, and what happened was I lost that that work. Of course, I cried over it because it was a month-long effort. Everything gone to waste. But if you're doing this in a project like this one, even if you were not able to save it and then there's power failure, and then when you open this again, it will still be here. Okay, it will still remain as untitled, but it will be there. You won't lose it. So let's just save it, and I'll just use script 0. Okay, I'll name it script 0. And notice that it's saved as type R. R stands for R script, and then save. Okay, now the name the name is different now, script 0. And then if I go here to files, you notice now script 0 is here. Okay, it's inside the project that we created. Okay, so we're not going to make use of the R script for our reports, for our cases. Rather, we're going to create another one, file, and then new file, this one class, R Markdown. Okay, so kindly create an R Markdown. Okay, I'll explain in a while why this is very important. All right, so let's just give this a title, maybe script 1. Script 1. Okay, author, of course, and give yourself name yourself. And then take note here, if I unclick this, the date is automatically, the date today is automatically produced here. Okay. Now, the disadvantage of this is later on, for example, it's already September 30. When you print this, it will still remain as September 2. However, when I click this, okay, notice this is grayed out. So it means that when you render this document, I'll explain later on what rendering means. When you render this document on let's say September 30, then what will appear here is September 30. Okay. Now, for an R Markdown, you can see that there are several types of documents that we can create. We can generate a document which can take the form of an HTML or PDF or Word. We can create a presentation out of this, of an R Markdown. Take note, you can create PowerPoint out of this. The advantage here, as compared to PowerPoint, is that you can create the codes in the PowerPoint itself, and then it can run. Okay. Unlike PowerPoint, where you don't have the capacity to run codes there. You just have to copy paste the results of any code in a slide. But for a PowerPoint created out of an R Markdown, it's linked. It is linked to R itself. Okay. Shiny is for websites. From template, these are other documents that we can generate. Okay. Now, we're running a bit out of time. In case I'm not able to discuss the whole breadth of this, I will post the session I had this morning. So I'm going to post two videos. Okay, one is ours, and the other one with the other section, because I think it will complement each other. Okay, so let's now just create an HTML document. So let's click OK here. And notice what happens. You'll have another document here. It's untitled. Why is it untitled? Because we haven't saved this. And it's quite different from the R script. This is an RMD file. Okay, let's save this first. File, save as. Okay, and then when we save this, notice that I'll name it script1 again. Script1. Notice that the default is RMD, R Markdown. So unlike the other one, the R script, this one defaults into RMD. So let's save this. And notice when you save it, class, you can now see here script1, and it's very unlike the script0, the R script file. This one is the RMD file. What's the advantage of an RMD file? Tons and tons and tons. So you can see here that there are different parts here. So the first one here is called the YAML. Here. This is the YAML. You have 3 lines here, 3 lines, and then title, author. Notice the date is not the date today. This is what I was telling about a while ago. R sys.date. So that when you render this or when you knit this later on, okay, it will generate the date of rendering. So this is called yet another markup language. Okay. Now there are other parts here. Notice that the codes are shown here in what we call, these are called code chunks. Okay. Code chunks. Unlike in the R script where the codes are just written anywhere, here, let's copy this, Control C, and then to create a code chunk, you have to type here, just like this one here, the backticks, and then curly brackets R, small letter R, and then backticks again. So this is a code chunk. Okay. Now, of course, there's a shortcut for this because it's quite long in typing it. Control Alt I there. So if you're using Windows, it's Control plus Alt plus I. If you're using Mac, I think, if I'm not mistaken, it's Command, please correct me, plus Option plus I. Okay. Command Option I, in Windows, it's Control Alt I. Okay, so let me redo this, right? Delete, Control Alt I. Okay, and then I'll copy the code here. Notice that the code is inside here. And when you run this, you can run this by going anywhere here and then Control Enter. Or you can click this, okay? Click this, and then the code runs plus the answer. Okay, here. The answer is here. All right, it's almost time, class. Let me just show you the rendering of this, and then we'll call it a day. And then kindly watch the ending portion of the first section, because we were able to complete the discussion of R Markdown. I just want to point out here, class, when you knit the file here, knit to HTML. Okay, knit it here, and then you can see here in the console that it will render here, render, and then you'll see some processing here. Okay, and then notice that it immediately generates an R Markdown, an HTML document. There you go. Okay, so this was what was inside the sample R Markdown file that we have. Okay, you can review what was there in the sample R Markdown. And okay, just to wrap this up, you can find here that in our where's our here, there is now another file here, HTML file. So this is what the result was. You cannot do this with the R script. You can only do this with the R Markdown. And if you check the files here, if we refresh this, you can now see that the HTML file, script1.html, is already here. Okay, so that ends our discussion for today. I'll again, please make sure to watch the ending part of the other section, kasi we were not really able to discuss in detail yung yung R Markdown. No? Okay? All right, so let me stop recording now.